the term, right?
Yeah. Okay, so we chose 3x squared plus 7x minus 6 equals 0. And we have to demonstrate how to write the equation into factor form, how to verify your solution using your calculator, demonstrate how to find the solutions, and explain the relationships between the solutions and the graph, and explain uses for the equations in factor form.
Yep, okay. So we're going to factor this equation. And the first step is taking the a, which is 3, and timesing it by the c, which is negative 6. So that gives you x squared plus 7x take away 18 equals 0. And then you just factor this equation, so that gives you x plus 9, and then x take away 2. And then since you times the 3 over to the 6, you have to divide both of them just by 3, which gives you x plus 3. And here you're going to slide the denominator back over by the x, so it gives you 3x take away 2. And that's your factored equation.
Oh, darn it. Oh, dang. You're doing math stuff.
It's a quiz, get out. We're taking a quiz, get out.
Is this a class right
like
now?
we're videoing, get out. Get out.
That was me.
Get out, I'm
You're
trying to get out.
videoing? Oh, I see that.
We're not starting over, everybody. You done that
You're
every
not starting.
time. Sorry,
Okay.
this is Stolbert.
To verify, you would just plug in both equations into the plot in your calculator. You would plug in the 3x squared plus 7x minus 6 and your factored form. And they line up on the calculator, so verified.
We did it right.
And then your solutions are just these two.
And you use the crazy x. So this one is negative 3, that's one solution. And the other one, since you have the 3x take away 2, you just slide the 3 under the 2 and change that to a positive, so it gives you 2 over 3, and those are your solutions.
And how those relate to your graph is that negative 3 is, they're both the x-intercept, because quadratics cross usually twice. So our graph would look something like that, yes.
Something like that.
And what you would use factor form for would just be finding your x-intercepts, and that happens, you can use that for finding things that go through the air into the ground. Okay.
Moving on to question 2.
Okay. So with this one, we have to find a rocket was launched off the shed of a roof, and so we're going to have to find a couple different things with a couple different equations. We'll have to find out how long the rocket was in the air, and explain what equation we used and why. And we have to determine how tall the roof shed was, so your initial height. And then you have to determine how high the rocket flew, so your maximums and your minimums. And then you have to determine the velocity of the rocket. Okay, so if you wanted to find how long the rocket was in the air, like we just discussed, if you wanted to use your x-intercepts, your factor form, because they give you the x-intercepts already.
And since the crazy x-axis, like that'll cross the x-axis at negative 0.123, and this one will cross at positive 7.623. And since time doesn't go into the negatives, we just don't look at that one. And so the rocket was in the air for 7.623 seconds.
And then how you determine how tall the roof was, you would use your standard form, because this 15 here is your initial height, and that's where it crosses the y-axis, and that's 0. So that's when time starts.
That's your standard form.
And then to determine how high the rocket flew is your maximums and your minimums. And so you'd use vertex form, because this is your highest point right here. And so you would figure out the rocket flew up 240 feet.
And then when you're looking for the velocity, you would also use standard form, because this number here is the initial velocity of the rocket. So the rocket's initial velocity was 120 feet per second. Yeah. And
that is done.
Yeah.